Welcome. The previous class I have discussed on about of that cycle addition reaction, that is 4 plus 2 cycle addition reactions, and I have discussed about of that MO representations of that Diels Alder reactions or 4 plus 2 cycle addition reactions. So today class basically what I am going to discuss is that the questions and answers. Also previous class I have discussed about of that stereochemistry. Okay, that exo products and endo products, so that the questions and answer that stereochemistry is very important, that will comes. So that things and that detail we will discuss today. We will solve the questions so that we will clear more. So let's start. If the questions is like this is the diene, and let's it have that here we have that methyls here, and here also we have that methyl here. Okay, now you have that. So let's, this is that things here, that is like this, and here we have the dinophiles, that is the dinophiles can be that wherever I'm discussing on that exo product and the product, what I said that diene will remain same, the orientations of dinophile will change. It means that it is the diene, so this will remain as it is, but the orientations of dinophiles will be either oxygen will be here, and that is like this. Okay, and here that, and here we have this. So if this type of the dinophile orientations is, this is the dinophiles, dinophile. So if the dinophile orientation is this sides, then here we are saying that exo product will form. Okay, now if that dinophile is, let's say this directions, and here we have this double bonds here, then on that times diene will remain as it is, diene is remain, that is going to be like this. Then here that what will form, that here we will get that here this is endo products, and this will be going to be the exo product that we have discussed in the previous class. And this endo product, it is the thermodynamic product, this is the kinetic products, and intermediate is stable here. Okay, so this is the more stable that we have discussed in the previous class. And the exo product, why this is more stable? Because here two interactions are possible, whereas that this exo product is, this is the thermodynamic product, and this is the less stable intermediate, that transition state will forms, because here only one interactions will happen, only primary interactions will happen here, both primary and secondary interactions is happened. So that we have discussed in the previous class. Okay, now what we look that according to this orientations of the dinophiles. Okay, so sometimes dinophile is this orientations, it means that O will come in this sides, sometimes O is going to that sides. Okay, so two types of orientations of dinophile is there. Accordingly that stereochemistry also will change. Here we see that the diene, here that orientations is this, here also the same orientations. It means that this double bond, let's say here also methyl is there, here also methyl is there, means that the orientations is same here, but the dinophile orientations will change. So according to change in the orientations of the dinophiles, that stereochemistry of the product will also change. Okay, that's how we will look now. Let's say we have the examples like this. Okay, let's say we have here methyls, and let's we have here methyl. Okay, and if let's say if we have the hydrogens here, and we have the hydrogens here, now we have the dinophiles. Let's say mm, dynapile is like this. This one. Okay, now in this, then how the stereochemistry, how the product will, if you give the heat, because that Diels Alder reactions always occur by heating only photochemical conditions, then the Diels Alder reactions will not happen, that we have discussed in the previous class. So if you give the heat, then how will happen, what how it will happen. So this will move to here, this is going to move here, and this is going to move here. So if you not understand, then just do the positive negatives, positive and negative. Okay, here this is positive, it is negative, and just mark it. This is 1, 2, 3 and 4, and this is 5 and 6. It means that here the bond will form 4 and 5, because this is negative and this is positive. Okay, so this negative and positive, one bond will forms again here. This is positive and this is negative, so the 1 and 6 again bond formations will happen. Okay, so this is going to be like this products. So here that bond formations will happen here, that is going to be the 6-member ring. Okay, and this bond has formed newly, this one and this one, these are the new bonds formed, and here that will shifted to this bonds. And the, if you name the name, that is this is 1 and this is 2, this is 3 and this is 4, and that 4 and 5 will make bond, and 6 and 1 has make bonds. Okay, 1 6 1 6 new bond, 4 5 4 5 new bond has formed. So this has formed, and what things we have, then at the 6 we have this ring, and at the 1 also we have this methyl, 1 and 4. So how it's the stereochemistry will be, we will mention that 1 is here, let's say I have that here methyls, methyl is there, here also methyl is there, but how, what is the stereochemistry of this methyl? Here 6 we have this this ring, that ring is this. But now the question is the, what is the stereochemistry of these groups, this and this methyl groups. So for looking the stereochemistry, what we look is, what actually we look is that look here. Now I will look that we consider only the above parts. So consider only this above. So for not for diene case, always consider the above double bonds always consider the above double bond for checking stereochemistry, for checking stereochemistry. Okay, so it means that we always look the double bonds, we will not look, and that the lower double bonds will be taken according to the above double bonds, and the below double bond, below double bonds stereo will be taken according to the stereo of above double bond. Okay, this we have to look that. Now what I mean that we will always look that for the dienes this above double bonds. Okay, this is the above double bonds. Above double bond means this is the above double bonds. Okay, so in this double bond, what we look that, so this is look that you are here, and you are facing to this directions, you are looking these directions, looking to these sides, it means that this is your hand. Okay, and if this is the one hand, this is the one hand, then this is going to be your this is going to be your left hand, and this is going to be your right hand. Okay, because you are looking to these sides, so this become your left hand, this is become your right hand. Because now after taking that making this left and this right by uh, standing, suppose you are standing here and you are looking to these sides, then what we say that this is your left hand, this is your right hand. Okay, now after that what you'll see that this methyl is in the out, because this is the double bond. For this double bond, this is out and this is the in, so this left is going to be the out and this right is going to be the in. Okay, so first make left and right, after that the make that which is out and which is the in. So for this double bonds, this H is inside and this methyl is outside. Okay, after that what we will look that accordingly the second the below double bond is taken. So now you will not take that by you are standing here and you are looking here, then this is your left hand, this is your right hand, that's we will not do. What we say that by considering the above ones, that that out one we say left means this is also out one and this is in, so this out one also going to be the left. Okay, why? Because we will take the stereochemistry of the below double bonds by taking that above one. Okay, by looking the above one, that way we can consider. That's what I write here. For diene case, always consider the above double bonds for checking stereochemistry, and the below double bond stereo will be taken according to the stereo of the above double bonds. Okay, it means that here what we write that this out one, I say this left is out, so out I say left means here also what I say that this is out, then I will say left. I will not write this is right, because if you are standing here and if your face is here, if you are standing here and if your face is this directions, then this is supposed to be going to your right, this is supposed to be going to your right, but we will not consider likewise. But we say that we will consider the above double bonds, and we say that this is the left because you are standing here. Okay, this only, these things only we will do for the above double bonds. Okay, so here we are standing here, then this is your left and this is your right. Okay, because you are facing it this directions, because and then this is your left hand, this is the right hand, and this left is out and this right is in, because this double bonds, this is outside and this is the inside. Okay, now once you say that this left one is out, then whatever the out, that will take as the left for this die. So for the case of the below double bonds, what you say that this is out, so that I will directly write left. Okay, this is out, so then I will say that this is left. Okay, because that in the above I already taken that the out means left, so here also I will do that, means this below double one stereo is taken according to the stereo of above double bonds. Okay, this is the for the diene case. And for the dienophiles, there will be whatever it will look like. You are standing here, you are standing here, then these are the left hand sides and this is your right hand side. It means that you are standing here, so these are your left sides and these are your right sides. So same things here, that it will not change, so whatever it will, so these all are become your left and these all are become your right. Okay, so which are the left hand sides for this case? So here if you have, here we have the hydrogens, here we have that hydrogens, so these hydrogens are left hand sides and this whole molecules is in the right hand sides. So accordingly we will do the stereochemistry of that. Okay, so one more thing, that if what I'm saying that if left sides, if I'm putting left sides is this, then left side, if I'm putting one this, then all left sides, that I will say that all left side molecules is considered this, or okay, that consider this, then all right sides is considered like this. Okay, or if all left sides is considered this, then all right sides will be considered by this dash. Okay, so that's we look that if left side you are considering by the dash, by weights, then all right side has to consider by the dash. Or if you all left side you are considering by dash, then all right side you have to consider by the weights. So that's we have to keep in mind. So applying that concepts, now I can do here, see that. So this bond has formed, this is the methyl here, and now this methyl is in the left, that means this is out and this is the left. And let's say if I'm putting that left, in this case if I'm putting the left in that wedge, then all left has to, I has to put in the wedge. Okay, so this is left, and here methyl is also in the left, this one also I will load that things by the left. And this hydrogen, this is at the 6, so this hydrogen is at the left sides. And here one more things that is apply is the concept is, one more concept that is, this is the diol, let's say, and dinophyl is that the dinophiles are two cases. This or dinophyl is can be okay, this is the dinophyl cases. Okay, so dinophyl is either this orientation or this orientation. So you see that the interactions where actually the bond form, so this is going to shift here, this is going to shift here, and this is going to shift here. So it means that this is one, and if I name that this is positive and this is negative, this is positive, then this is negative. And if I mark here, let's say this is 1, this is 1, this is 2, this is 3, this is 4, okay, and this is 5, and this is 6. And what is in that, let's say this is positive and this is negative, then the bond formation is happening at 1 and 6 and 4 and 5. So how the bond will forms here, so this is going to shift here, and here that new sigma bond will forms, and again here that new sigma will form. It means that 1 and 6 one bond is forming, and 4 and 5 one bond is forming. So how it will be look, okay, so here that bond is coming here, and this one let's say if I take that, this is 1, then this is 2, this is 3, this is 4, this is 5 and 6. It means that 1 6 new bond has formed, 1 6, and another is that 4 and 5. So this here that new bond has formed here. After that this group is there, that is this groups, this group is there. So what we see that this 1 and 6 and 4 and 5, it means that this position, this carbon atoms and this carbon atoms, these are here that bond is formed, means that these interactions must be present, because here actually that new bond is forming, that's why you get that this molecule. So whatever the interactions that will happen here and here, that is what we say that these are the primary interactions that we have discussed in the previous class, because for this new product is forming. So these are primary interactions. Okay, these are the primary interactions. So what we see that while naming the product in a molecules, then what we say that these position carbon atoms, this position carbon atoms and this position carbon atom, this carbon atoms always taken as 1 and 1. This also will take 1 and 1 because here that new bond is going to form. Okay, and these are the secondary interactions. So you will take this as 2, this is 2, and this is 2, and this is 2. Okay, so likewise we can take that where actually the bond is forming, that is taken as 1 1. This is also 1, this is a 1, and that this is the secondary interactions that we have discussed in the previous class, that is taken as 2 2. This is 2 2. Okay, so now what we say that, so if I erase all this, okay, so now what I say that this is 1 because this is the primary interaction, this is 1 and this is 1 and this is 1 because here that bond has to pop. Okay, this is 1 and this is 1 1 and this is going to be 2, this is going to be 2. This is the secondary interaction that I have discussed in the previous class because first here the bond has to pop. Okay, that's why this bond is formed, this 1 and 6 and 4 and 5. So this and this we make the 1 1 and this is the secondary case, this is 2 2. Okay, so now what we see here, this is 1 and 2. It means that this is 2 1 and this is what, 1 and 2. And for this case what we looked at, this is the interactions where actually bond will form. So this is going to be 1 and this is 1, this is 2 and this is 2. It means that this is, here what we get that 2 1 and this is 1 2, but here what we see that this is 2 1 and this is 2 1 because here that will be same. This is again going to be that 1 and this is again going to be 2. So 2 1, this is 2 1. So whenever 2 1 and 1 2 will change, then stereo will change. Stereo of dienophile will change, not dine, only dienophile will change. Stereo of dienophile will change. And if that's 2 1 and 2 1, then only the stereo of dienophile, the stereo of dienophile will not change. Okay, so stereo of dienophile will change, and the stereo of dine is always that whatever it's that will remain as it is. So stereo of dine, that will not affected. Okay, stereo of dine not change. Here also stereo of dine will not change. Dine not change. So either this, both the cases stereo of dine will not change. Okay, but if this is 2 1 and 1 2, then stereo of dienophile will change. But if it's 2 1 to 1, then stereo of dienophile will not change. So this, the some facts we have to remember. Then we will solve the stereochemistry of the dine and dienophiles for the Diels Alder reactions. Okay, it means that what I said here, if dine is like this and if dienophile is like this here, okay, then what we looked at, this is the primary interactions 1 and this is 2. This is the primary interactions. First name that primary interactions, this is 1 and 1. Okay, and the secondary 2 2 and this is going to be 2 2. So this is what, 2 1 and this is 1 2. Okay, 1 2. So here stereo of dienophile and change. So only stereo of dienophile will change. For dine there is that not change. Okay, stereo of dine not change. And other case, is that if this case, and if that is like this, then what we see that first we will put that primary interactions. This is one, this is one, and this is one, and this is one. These are the primary interactions. So 1 1 1 1, because these interactions needed to make the bond. Okay, 1 1, and this is going to be 2, and this is going to be 2, and this is 2, this is 2. It means that this is 2 1, and this is also 2 1. So no change in stereo of dinopiles. And also diene, because diene there is no change in the stereochemistry both for these cases. Okay, so if it is 2 1, if it is 2 1 and 1 2, then stereo of dinopile will change. But if it is 2 1 and this is 2 1, then no change in the stereo of dinopiles. Okay, so this is some concept you look has to memorize, you has to keep it, then we will solve the stereo of Diels Alder reactions. Okay, now we will solve these questions to get clear more. So in this first questions, what it says here, so first we will put that primary interactions. This is primary interactions. Okay, so first name that 1 and 1. Okay, and this is again, this is the primary interactions 1 and 1. Then this is going to be 2, this is going to 2. Here that is not there, so simply leave that. Okay, now what you will do, that just move here and move here. It means that this is positive, this is negative, this is positive, this is negative, and that move here, this is positive, this is negative, and it is positive. And if you confuse with how bond is formed, then just name it, that is, we can name here this is 1, this is 2, this is 3, this is 4, and this is 5 and 6, means 6 member ring will form. Okay, and here 2 3 bond is here, count 1 2 3 4 5 and 6. So 2 3 double bonds will form, and 4 and 5 that ring has formed, 4 and 5 that new sigma bond has formed, and 1 and 6 new sigma bond has formed. Okay, this is the what the ring has formed. And here that triple bond is there for 5 and 6, but one has used to form the sigma bonds, then double bond is there. So this is the products. And now that since this is again in the double bonds, and what we know that double bond is plane, because this is sp2 hybridized. So this the substituent also, because this is in the double bonds, substituents are there, so this is remain as a plane, because in the plane we will not decide, because if the molecule is plane, then the substituent attached to it is also remain as plane. Okay, so double bond is plane because this is sp2 hybridized, so substituent attached with double bonds also in plane. Okay, sorry. So that is also remain the plane, but now only you have to look at this stereo. Okay, now you are standing here and you are looking this sides, it means that this is your going to be your left sides and this is going to be your right sides. Now if it is left, then this is the out. If it the double bonds, this is going to be the out. Okay, and by looking this above double bonds, we will take that for the lower double bonds. So this out means left, and this is also out, then this is also going to be the left, and this is again going to be the right. Okay, so that's we has to do the stereo, that is 1 and 4. 1 and 4 is that there, so this is 1 and 4, and this left, that this is the left. If left, if I consider this wedge, we can wedge or dash, anyone we can consider. If it is methyl, then this is also in the left, so all left will be taken at the wedge. Okay, and this hydrogen is on the right, so we can take that hydrogens. Now this is, since that this double bond is there, so this stereo or this substituent also in the plane, it means that COO we will simply write like this, because this is in the double bonds, and since this double bond is plane, because this is sp2 hybridized, so this substituent also in the plane. Okay, so this is the final product for these questions. Now moving to the next questions. Here also the same concept is there, just that here methyl, here hydrogen is there. Okay, so what we see here, that the same things we will show, that the primary interactions, this is where double bond must be, the interactions must be needed, that is this and this, so you put here 1 and 1. Okay, this is again 1 and 1, because what you see, that double bond will forms here, so these are the primary interaction, that's why I put this is the 1 1. Okay, and this is going to be 2 and this is going to be 2. So now what we will do, that just move the bonds here. Okay, then we will make that 6 member rings, that we have to solve that, and this is going to be like this. Okay, now what we look, that you are standing here, and this is and you are looking this side, it means that this is going to be your left sides, and this is going to be your right side. And left means this is, for this double bond, this is outside, so this is out, so here this hydrogen is also out. It means that by considering the above double bonds, lower double bonds is taken accordingly, above the lower will taken. It means that here I take that left to out, then all out is going to be the left, means this is also out for this double bond, this is the outside, this is inside, so since here out I taken left, so this I also I will take the left, and this is going to be again right. Okay, so that's I will do here, and this is again going to be in the plane, so double bond is there, that planar means this also in the plane, so here the stereochemistry will be there in the plane. Now for this we have to do that, since if I take left as this, or let's take now left as this, means all left I have to take as this, so here also this is left, this is out, means this is also left, so this also I will take as this. Okay, now this H is the in, and that is what I have taken, this is left, then this is going to be right, so this is what I am taking, that like this H, and this is also means that one left is wedge, or one left is in the dash, then all left has to take in the dash, so this methyl also I will take in the wedge. So this is the final questions for this, for this is the final answers for these questions. Okay, moving to the next questions now. Okay, for these questions, now the same things I will take here. What you take, that primary interactions first we will do, so this is the primary interactions here, so take that this is 1, then this is going to be 1, because here actually bond is going to form, so this is the primary interactions, and this is also 1 and this is also 1. Okay, now what we will do, that we are standing here and this side we are looking, so this is going to be your left, and this is for this double bond, this is in the out, so all out will be taken as left, because why, because according to the above double bond, lower double bond stereo will decide, so this is out is left, so this is also out, so this is also going to be the left. Okay, then this is right, then this is also right. Okay, so now for this, what you see, that this is 1 and this is going to be the 2, It means that this is here 1 and this is the 2. So this is 2 1 and this is 1 2 1 2. So 2 1 and 1 2 is there, then stereo will change. What I say that 2 2 1 2 1, then no change in stereo, but if 2 1 and 1 2, stereo will change. So always remember that if same, then no change in stereo. If the different like 2 1 1 2, then stereo will change. If same 2 1 2 1, then no change in stereo. Okay, so here what you get, 2 1 and 1 2, so stereo will change. Okay, if 2 1 2 1, no change stereo, but if 2 1 1 2, or this is always 2 1, and here if 1 2 or 2 1, if 2 1 2 1, no change, 2 1 2 1, no change, 2 1 and 1 2, then change in stereo will occur. Okay, so here the change in stereo will do. It means that what you do here, look these questions, uh, this is left and this is left. So for dyne, that stereo will not change, only dynophile stereo will change. It means that you are standing here. Okay, you are standing here and looking to the above sides, looking above sides. It means that these hands are your left hand sides, these hands are your left sides, and these hands are your right sides. It means that these are left hand, these are the left side, and these are going to be your right sides. Okay, because you are standing here and you are looking in the above. So this left, since this is 1 2, so this left is going to be the right. Okay, so that's we has to remember that, because this is 1 2, and accordingly you are looking in the above, then this has to be left. Okay, this is left, and this is also, this is left, this is also left. But since this is 1 2, so this left is going to change to the right, and this left is going to change to the right, and this is the right, and this right is going to change to the left. So that will occur for the dynophiles if this is 2 1 and 1 2. Okay, so why this left and right is important, because here also we have the left, here also we have the left, here also we have the right. And what things we know, that if one we will put left, then if one left we will put wedge, then all left we have to put in the wedge. And if one right if we put dash, then all right we have to put in the dash. Okay, so that's why that left right for this dyne and dynophile is important. Okay, because we are combining these two one, because we are combining these two subtracts. If one subtract is left, here also left is there, so that left combining will make that one left is dash, then all left has to be dash, and one right is wedge, then all right has to be in the wedge. Okay, so how the product will form, so we know that this is going to shift, this is going to shift here. So 1 2 3 4 and 5 6 membering will forms here, and this is coming to be here, and this left. So if I take the left, let's say if I taking left as the wedge, here methyl, so this is also in the left, so this one also I have to take in this directions, methyls. Okay, and here that bond form is occur here, and this left is changed to the right. Okay, and here that right is I am taking right as the dash, so here h, here also right is h, so I am taking this as h. Okay, now here what thinks, this left is changed to the right, so right means this this left, this in the left, and this in the right. So this is here this h is left, but this is 1 2, that's why it changed to right. It means that I have to take this h also in the right, it means that this. Okay, and this bond will forms here, and this methyl, this is again left, but I have to change to the right, and right I am taking as a dash, so again I will take the methyls here. Now if it is in the this is left, and then that going to be the right, so this put, and this is right, but that is going to left, and left one I am taking the wedge, so this molecule I has to take in the wedge side. It means that is going to be these sides, and okay, so this is the final product for these questions. Okay, likewise we will solve the questions. This one we can put a little bit. Okay, and input the hydrogen. So this is the final answers for these questions. Okay, likewise the next questions we can solve. Okay, for these questions, for these questions what you see that again we will do that primary interaction. This is one, with that here. So so for these questions again we will take same way. So this is the primary interactions. This is one, this is one, then this is 2, and this is 2. Similarly this is the primary interactions. This is 1 and this is 1, this is 2 and this is 2. It means that this is 2 1 and 1 2, means stereo will change. Okay, 2 2 1 2 1, no change in stereo, but 2 1 and 1 2 stereo is going to change. So change in stereo. Okay, so now what we will do here, now again we will take that we are standing here and you are looking this sides. It means that this is going to be your left, and this side here hydrogen is there, this is going to be your right. And what you look at in this double bond, this is in the outside, so this is out. Okay, now this is again for this double bond, this is out, so out means left, I will take as the left. Okay, now same things here we will do that. You are standing here and you are looking this side, the above, so these are going to be your left and these are going to be your left. And since this is 1 2, so this is left is going to change to the right and this left is going to change to the right. So what I say that only change in stereo of dinopile will occur, the no change in stereo of dine. So dine is remain as it is. Okay, how you do that, same things we have to do. Only dinopiles the stereo will change if it is 2 1 and 1 2. Okay, so this left is going to right and this left is going to right, and these are in the, these things for this double bond, these are in the right sides, and that right is going to change to the left. Okay, so now make the bonds here. So how many ring will form? 2 3 4 5 6. So 6 member ring is going to form. Okay, and this is going to shift here, this is going to here, so this is here double bond will form, and here that new sigma bond has formed, here new sigma bond has formed. So here that methyl is there and methyl is left. So if I take me left as the dash, that says, then right, this is the left, and then right I will take that in the wedge, that is H, this is the actually right. So now this is again the left, so all the left I have to take in the dash. So this is again I am taking as methyls. Okay, and this is the hydrogens here, and now here that new bond is for here this ring is there, so make that also here. I'm going to make this. Now what you see that this is that hydrogens is in the left, that is I making in the right. So right means I shows in the wedge, so this hydrogen also I will shows in the wedge here hydrogens. This hydrogen also in the right, right means I shows in the wedge, so here also I will show in the wedge. It means that this whole molecules if it is that is wedge, then this has to be in the dash. Okay, so because this right and left I am showing in the dash, so this is going to be the dash. Okay, so this is the final answers for these questions. So likewise we will solve the questions. Now moving to the next questions. Okay, this is the very interesting questions here. So what that here they combine that electrocyclic reactions questions. So if you given that heat, then on heat what will happen that on cone rotations that bond formations will occur. Okay, this is the pole pi systems that we have discussed these questions. It means that this is the pore member ring, so strain is there. That's why what will happen that this is going to shift here and this is going to break here. Okay, now which bond is break, that the stereo will decide. So this bond is breaking, whatever the sigma bonds that is break, so on that carbon atoms the stereo will define. Okay, so this sigma bond is going to break, so carbon atoms to this bonds the stereo will going to decide. It means that one is this is in the trans. So since this is the cone rotatory, so cone, if trans is there, then that is going to the cis. So that what we are going to get here. Okay, so this is trans, so that going to cis. It means this is going to be like this, and this double bond shifted here. Okay, and cis means what we know that if one is out, then all has to be out. It means that if one methyl I do here, then other methyl also I have to here, because what we know that out is going to be cis, or in and in is going to be the cis. Trans is out and in, then that is going to be the trans. Okay, so this is out, so this is I change into the cis. Okay, so first it will happen, after that it will do the reactions with this. It will do the reaction. Okay, first it will do, after that it will do the reactions with this. Now what will happen here, now that cycloaddition reactions will happen, because this is the diene case, this the diene will get. Okay, so this diene what will do that so this is going to be so this is the dienes what we have got, because this is shifted to here. So this is the dienes what we get. Now here that rotations will occur. This is the primary interactions, because here the new bond is going to form. This is one and this is one. Okay, and this is one and this is one. But see that here this is the COME, so this is going to be COME. So it means that here also interactions can possible. So this is 2 1. It means that this is 1 and this is going to be 2. So this is the 2 1 and 2 1 case. It means that 2 1 2 1 means no change in stereochemistry. It means that what will happen, the product will be going to be 1 2 3 4 5 6, 6 member ring will form. One is already 6 member rings, then here again 6 member rings will form. Okay, and this is going to shift here and this is going to make the bond. It means that here it will comes here, the 6 member ring is there, and this is that this is the 1 1. So here this methyl here, what you see that if you look this double bonds, and if you are standing here and you are looking to these sides, then what that this is here going to be your left sides. This is going to be your left side, and left is that is in the out. So this is also going to be the left side, because this is also in the outside. Okay, and now in this case what we look that this is the case 2 1, so no change in stereochemistry. So this is going to be shifted to that one. Then what we see that let's say if I'm putting this one in this way, that is the wedge, here methyl is there, here methyl is there, then what we see here, that is going to be that so if you are standing here, then this side is going to be your left, and this is going to be your right. Since this is 2 1 2 1, so no change in stereochemistry. So what we will see that one COMe is if we are putting that one is right here, then this is one is right and one is this is right and this is the left. So left one I will put that this way, COMe. The right one I have to put like this. Okay, so this is the final answers for these questions. Now moving to that last questions. So that just I will erase it. Okay, so last questions today. Okay, so this is the last questions for the Diels Alder reactions. Okay, so for these questions, what we see that this is again in the same case. First we will look at primary interactions. So this is that I did the wrong. So this is it's going to be that like this. This is the diene. Okay. So this is the primary interactions 1 and 1. This is 2 and this is 2. Now what is seen here? This is the electron donating groups. Donating groups. And electron donating, this is the strong electron donating groups. This is the electron donating group but weak electron donating groups. And this is the dienophile. So for dienophile, what you see that electron withdrawing group increase the reactivity of dienophiles, but electron donating groups, what they will decrease the reactivity of this dienophile. It means that this electron donating groups, so this dienophile will not do. This dienophile we will consider. Reason is that here we have the strong electron donating group which decreases the reactivity. It means that this double bond will not participate, this double bond will participate. Reason here electron donating group is there, but this is the weak electron donating groups. Okay, that is the main reasons that they give in these questions. Okay, so now if we do that reactions, then what this is going to be 1 and this is going to 1. This will not participate, this will participate. So that 6-member ring will form 1 2 3 4 and 5 6. This 6-member ring will forms. This is going to shift here. Okay, and here that things is not there, so no substituent because hydrogen is there, so no need. Now here we have to that this is participate. Now you are standing here, then these all are going to be your left sides and this is going to be your right sides because you are standing here and you are looking in the above sides. So what you look at, this methyl is going to be the right side and this is the case. Okay, this is the 2 1 and this is also first, this is 1 and this is going to be 2. So this is 2 1 2 1. So 2 1. Okay, this is 2 1 and this is also, this is 2 and this is 2 1. So 2 1 2 1, no change in stereochemistry. So if it is left, then that is remain as left, and it's right, then that is remain as right. So if I take that let's take this methyl as that wedge. Okay, you will take this as wedge. Let's take this one and If I taking this one and if I take like this, then what that here, this is going to be that bonds here that is not get affected, and here we have that OME, and here we have that this, and this means this is in that wedge, then this methyl is, so if one we are taking that wedge, then other we have to take the test. So this methyls and these hydrogens are in the test. So this is the final answers for these questions. Okay, so likewise we will take that stereo and we can solve the questions related to Diels Alder reactions. Only one thing you will remember is that all left side you are taking wedge. If you want left side take wedge, then we have to take all left side at the wedge and all right side at the test, or vice versa. And what things that we will consider by taking the double bonds, but like you are standing here and you are looking this sides, then this is going to be your left, and this side is going to be your left, and this side is going to be right. So according to the double bonds of the above of dienes, the lower double bonds will taken. It means that if it is out is left, then this out also has to be the left. Okay, that is for the dienes. And for the dinophiles, that if 2 1 2 1, then the dinophiles whatever the stereo we will get, the same stereo will write. It means that if it is left, then that remain as left. If it is left, that remain as left. If it is 2 1 2 1, and if it is 2 1 and it is 1 2, on that case, this if it is left, then that is going to be the right, and if it is right, then that is going to be the left. Okay, so these things we has to memorize, we has to remember, then we can easily solve the stereochemistry related to Diels Alder reactions. So today up to this, we will discuss more in the next class. Thank you.